In this video, we'll look at an example of a simplified example of a correlation matrix. When you read research articles, they will describe in text what some of the relationships are, but they will probably also include a table that looks like this that shows the correlations between the data points that they're using. They can have multiple data points. So in this example, they're comparing education, income, attitude, and how people vote, and what is the relationship with each of these. So obviously, if we have a data set for income, it's going to be perfectly correlated to itself. One of the things that you'll notice in there is there will be a perfect correlation for the values that are related to themselves. Sometimes you'll just see those as blanks, that there won't be anything there because there's no point in putting them there. The second thing I want you to notice is the data very often will be duplicated. The correlation between income and education, which in this case is 0.574, is obviously the same as the correlation between income and education here. It's the same data. Here we can look at income and attitude. It has a negative correlation of 0.08. And here it is up here. Now, often what we'll see happen is the upper right hand corner of a correlation table will be blank because there's no point in putting the extra data in there. It just sometimes tends to confuse people, so they'll leave it out. So let's kind of focus on the bottom left hand side of this. As we said earlier, not only are we interested in correlations, we're interested in significant correlations. So in this example, we might ask, well, what is a significant correlation? This one, the relationship between income and education, is a statistically significant correlation. Its correlation coefficient is 0.574. So it's a positive correlation, and it's significant at the 0.01 level. And you'll see these asterisks here that correlate to a symbol down here. Now, another correlation that's significant is this one, the relationship between income and vote. That correlation is a negative 0.291, and it is significant at the 0.05 level. Now, those are the only two significant correlations in this study. This is not significant. This is not significant. Sometimes what you'll see is a correlation that looks like something like that. And I might ask a question about which one is more significant, or which one is the stronger correlation. Even though this is negative, because the number is closer to 1, the absolute value of 1, this becomes a larger correlation than this one up here. Something else to consider, if we had two correlations, let's say that this was 0.574 also, but we're only sure at the 0.05 level. We can be more sure about this relationship because it's the 0.01 level than this relationship at the 0.05 level. So those are some aspects to keep in mind as you're looking at this, that just because something's negative, that doesn't mean it's a weak relationship. It can actually be a stronger relationship than a positive one. And in all things being equal, if we can be more sure about the data here than here, this one gives more value to what we're investigating.